Transformer efficiency and the transformer equation. Efficiency is the amount of useful energy obtained from a system. A transformer is a system that takes in energy and gives an output. Transformers are not 100% efficient due to a number of factors. The main factor is actually resistance. Due to resistance, the loss of energy that is supplied to a transformer is lost in form of heat. This heat is generated due to resistance in the coil and also resistance in the core. This resistance in the core is caused by eddy currents. Eddy currents or current generated in the iron core of the transformer. Therefore, iron is not a very good conductor of electricity, so the little currents that are generated, or the eddy currents generated in the core, face a lot of resistance, making the core be one of the main producers of heat or generators of heat in a transformer. How is this heat controlled, or how is a transformer cooled? A transformer is mostly cooled by a number, or let me say by its, through its design. One thing about the design of transformers is that they have what we call heat sinks. Heat sinks appear like slits in the design of a transformer, which are made of good heat conducting metals like alloys that have aluminium and copper. Therefore, that way the heat is lost from the transformer by radiation. The other way through which heat is lost from the transformer is through oil, transformer oil, which dissipates the heat away from the transformer. The transformer oil dissipates the heat away from the transformer and also acts as an insulator, because the transformer coils and the core, the whole of this arrangement is dipped into transformer oil. Remember, the coils are actually varnished or insulated. They're not really naked, so there's no connection between the coil and the core. Therefore, current only passes in the coil, but there is current in the core because of the alternating magnetic flux or field that is generated by the alternating current in the primary coil. Okay, below here is just a symbol for a transformer, just a symbol: primary part, secondary part. The transformer efficiency equation can be, or is written as E, which is efficiency, is equals to power in the secondary over power in the primary, times 100. This is the same as efficiency is equals to power output over power input. Remember, the secondary is the output part of the transformer, then the primary is the part where the energy or the electric energy is supplied. Remember, power is equals to voltage times current, VI. So the equation for efficiency can be rewritten as VI over VI. Therefore, the V in the secondary, current in the secondary, over current and voltage in the primary, times 100. Efficiency is only 100% when the transformer is said to be ideal. Therefore, you ignore all resistance and all opposing forces. Therefore, the power input is always equal to the power output when the transformer is 100% efficient or is said to be ideal. The second part is simply the transformer equation, which relates the output to the input using the aspects of voltage, current, and number of coils. Therefore, the transformer equation, is as below. Therefore, number of turns in the primary over number of turns in the secondary is equals to voltage in primary over voltage in secondary, equal to primary secondary current over primary current. This equation, which is our transformer equation, can be split where you ignore this part, or you can ignore this part, or you can ignore that part, depending on how the question is phrased to you. When you observe this part here, you observe that this is actually power input and power output, because when if you cross multiply here, you're going to have VP IP is equals to VS IS. Therefore, power in the primary is equals to power in the secondary only when the efficiency is 100%. basically that's what I wanted to share with us today. And for any question, I'll look for a question and solve a question that will involve the two equations, and see how we can work or go about using the information that we've just covered. Remember to subscribe and leave your comments if you'd want me to look at any other topic in physics, secondary school physics, and chemistry, and even biology. Bye for now.